Names in organic chemistry have three parts. They have a prefix, they have an infix, and they have a suffix, and each of those parts tells you something, gives you some information about the structure of the molecule. The prefix tells you about the number of carbons. The first four prefixes, there's really no way around it. You would just want to memorize those. If you have one carbon, the prefix is meth. 2 carbons, the prefix is eth. 3 carbons, the prefix is prop. And 4 carbons, the prefix is bute. I've seen maybe one kind of silly mnemonic device. It's me eat peanut butter, if that helps you remember those. But those are for the first 4 carbons, and so you'll want to commit those to memory. For the rest, you'll also want to commit to memory, but these might seem more familiar. These would come from Greek prefixes. So for 5 carbons, the prefix is pent, like the pentagon has 5 sides. 6 carbons, the prefix is hex, like a hexagon. 7 carbons, the prefix is hept. 8 carbons, the prefix is oct, like an octopus. 9 carbons, the prefix is non. And 10 carbons, the prefix is dec. So those are the prefixes you would want to know by heart. And that's the meaning behind them. They're telling you about the number of carbons in your molecule. The infix tells you about bonding. So if you have all single bonds, the infix is AN. If you have at least one double bond, the infix is EN. And if you have at least one triple bond, the infix is YN. And these originally came from the vowels. So the vowels in English are A, E, and I. Those are the first 3 vowels. So single bonds A, double bonds E. Triple bonds were originally I, and they got changed to Y over time. So if that helps you remember those. Last but not least, you've got these suffixes, and the suffixes tell you about something called functional groups. So remember that organic chemistry is the chemistry of carbon, and the special thing about carbon is that it can form stable bonds with itself. That allows it to form long chains, chains that have branches, branches that have branches, rings, rings that connect to other rings, rings that connect to straight branches, and so on. So there's an infinite variety of shapes that carbon can form, and as we discussed in Chapter 1, it's the relationship between those shapes that encodes messages, and it's the shapes that determine how molecules literally, but also figuratively, fit into the world, and the role that they play. So that's exciting, an infinite variety of molecules in organic chemistry. But also, how do you organize that? How do you study that? How can we go in and say, okay, in 2 semesters, we're going to know about all these infinite molecules. After that, put a molecule in front of me, and I'll pretty much know about it. And the way you can do that, the reason why you can do that, is because of these things called functional groups. On all of those crazy carbon chains, there are groups of atoms that reappear and that always behave or function the same way. For example, an OH, an oxygen bonded to a hydrogen, that could appear on lots of carbon chains. And when it does, it always functions the same way, no matter what carbon chain it is that it's on. And so those groups of atoms that always function the same way are called functional groups, and they're what let you study organic chemistry, really. Because even if you see a molecule that you've never seen before, if you notice the OH on it and you know how that group functions, then you know how the new molecule you're looking at functions. Excuse me. And so those functional groups are represented in the suffix of the name. Now in Organic Chemistry 1, the functional group you deal with most often is just hydrocarbons, molecules that only have hydrogen and carbon in them, and the suffix for those is E. But just for the sake of comparison, we were talking about having that OH on molecules, and you'll see this toward the end of Organic 1. You'll study these. That functional group, if you have OH on a molecule, is an alcohol, and the suffix that represents that is OL. So for example, drinking alcohol and rubbing alcohol are not the same molecule, but they are both alcohols because they both have this OH on them. And in both of the molecules, the OH behaves the same. And in other molecules, the ending OL is telling you that an alcohol is there. So for example, in cholesterol, it's ending in OL because there's an alcohol in the molecule. Okay, Let's just do a little quick practice with this before we dive into the homework exercises. Let's see if we can name just 2 molecules. Really simple, really straightforward. Let's try this one on the left. So how many carbons do we have? We have 1, 2, 3. What's the prefix for 3 carbons? Prop. So that's the prefix for this molecule. What's the bonding like? Do we have all single bonds? Any double or triple bonds? All single. So the infix is AN. And finally, what are the functional groups like? Do we only have hydrogen and carbon, or are there some other weird atoms? And if you have anything other than hydrogen or carbon, it will have to be written in. So for example, if oxygen is there, you have to have an O. If nitrogen is there, you have to have an N. If a sulfur is there, you have to have an S. If you don't see the symbols for any other elements, then you know it's a hydrocarbon. And so you put the suffix E. So the name for that molecule is propane. That's the molecule that you use in gas grills. They sell it in tanks at, say, a supermarket. Okay, just for the sake of comparison, let's try to name this next one. Here we have 1, 2 carbons. Notice this is not a carbon. That's the end of this bond connecting the oxygen to the carbon that we've numbered 2. So 2 carbons. The prefix for 2 carbons is F. If you look at the bonding, it's all single bonds, and so the infix for all single bonds is AN. And then for the suffix, you would look at the functional groups. Do you only have hydrogen and carbon, or do you notice some other element there? We do have another element. You see the OH. That's an alcohol, and the suffix for an alcohol is OL. So the name for that molecule would be ethanol. Ethanol is drinking alcohol. So you can see how those names, which are really very short, are giving you a lot of information about the structure of the molecule. So let's take a picture of this table. You would want to commit this table to your memory, and we're going to use this to name some molecules in a second. Okay. Okay, so here, this exercise is just asking you to give the name for the parent. So let's talk about that. Now in the molecules we were naming just a second ago, you just had a straight chain of carbons. You follow the chain and you count the carbons up and you're done. But in these, what you'll notice is that they have forks in the road. They have places where you can go down the molecule from one carbon to the next, but then you get somewhere, and where do you go? Do you go up and to the right, or you go down? And in those molecules, you have branches. So anytime where you have a fork in the road, the first thing you want to do is to identify something called the parent chain, and sometimes that is also called the backbone. So the parent chain or the backbone. The parent chain or the backbone is the carbon chain, the longest carbon chain you can find without lifting up your pencil or going backwards. So for example, in this first molecule, you could imagine having 1, 2, 3, 4. Now there's a fork in the road. I could go 5, 6. So that's one possible path I can go down in this molecule. Alternatively, I could go 1, 2, 3, 4. Now I'm at the fork in the road, I could go the other way, and it could be 5. I can imagine another path I could go down in this molecule. I could start here, 1, 2, 3, and then go to the right, 4. So you see these different paths in this molecule. The one that's the longest, so the longest carbon chain you can find without going backwards or lifting up your pencil, that's the parent chain. And in this example, that's the orange numbered chain. So once you find that, and it's worthwhile noting, we read from left to right, so it's always tempting to think that the backbone is left to right. Resist that temptation. It's a very common mistake. What you want to do is find the longest carbon chain without going backwards or lifting up your pencil. So I encourage you to circle that chain. It will help it to stand out from the branches a little bit better. Okay, and so let's just name that parent chain, or that backbone. And then we'll worry about the branches in a future problem. In this exercise, we just want to identify the parent chain and name the parent chain. Okay, well, we have 6 carbons. 6 carbons, so the prefix is hex. We have all single bonds in that orange circled area, and so the infix for all single bonds is AN. And we have a hydrocarbon. I don't see the symbols for any other elements there, so it's just hydrogen and carbon, the suffix is E. And so the name for that parent chain is going to be hexane. We can follow a similar process of thought for this next molecule. So let me actually use these colors. So let's look at the different paths we can take across the molecule to try to find the parent chain. So we could go 1, 2, 3, 4. So now I'm at a crossroads. I could go up 5, 6. I could have gone 1, 2, 3, 4, and instead of going up, I could have gone to the right, 5, 6, 7. And I could have even started up here, 1, 2, 3, and then go 4, 5, 6. So those are different possible paths you could take across the molecule, but you'll notice one of them is the longest, and that's the purple one. So the longest carbon chain you can find without going backwards or lifting up your pencil, that's the parent chain. I encourage you to circle that. And we'll name that as if there were no branches on it. In a future exercise, we'll talk about how to name those branches. But for now, let's just name this. We have 7 carbons. The prefix for 7 carbons is hept. We have all single bonds. The infix for all single bonds is AN. And we have a hydrocarbon, because there's no symbols for other elements there, so the suffix for hydrocarbon is E. And so the name for that backbone would be heptane. Okay. We go to the next molecule. We want to find the parent chain. The parent chain is the longest straight chain you can find without going backwards or lifting up your pencil. So it could be 1, 2, 3. I could keep going, 4, 5, 6, 7. That's pretty long. Another possibility could be 1, 2, 3, 4. Okay, not quite so long. It could have gone 1, 2, 3, 4 and gone up 5. Or I could have even started here, 1, 2, 3, and gone down 4. But notice the longest carbon chain that you can find without going backwards or lifting up your pencil is the brown one, the one that's 7 carbons long. So I'm going to erase all the other ones. That brown one is going to be my parent chain. So I'm going to circle it so it really stands out from the rest of the molecule. It just visually helps me to organize this. So now we'll talk about how to name the branches in a future problem, a future video, but first let's just name that backbone. There are 7 carbons. Prefix for 7 is hept. There are all single bonds in that backbone. All single bonds, the infix is AN. And it's a hydrocarbon. Only hydrogen and carbon in the molecule, so the suffix is E. And so the name for that backbone, again, would be heptane. Okay, let's try this next one, D. So one possibility is just left to right. 1, 2, 3, 4, 5, 6, 7, 8. So we're looking for our parent chain here. Alternatively, you could have 1, 2, 3, 4. Instead of going right, I could go 5, 6, 7, 8. Interesting. So now we have a tie. Or you could go 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice how we're so tempted to look just left to right because that's how we read. But in these structures, it's not left to right, it's not up to down, it's whichever path gives you the most carbons without going backwards or lifting up your pencil. And so here, that's the green path. And so that will be our parent chain or our backbone. So I'm going to circle that. I would encourage you all to always circle the backbone so it really stands out from the rest of the molecule. So we'll learn how to name these branches later. For this exercise, let's just name the backbone. We have 9 carbons there. The prefix for 9 carbons is known. We have all single bonds between those carbons. The infix for all single bonds is AN, and it's a hydrocarbon. I don't see any symbols for elements in there, in that chain, so we only have hydrogen and carbon. The suffix is E, and the name for that backbone or parent chain would be nonane. Nonane. Okay. Let's do the similar thing for E. So we look left to right, we're always tempted to read that way, so 1, 2, 3, 4, 5. That's one possibility. Another possibility could be 1, 2, 3, and go up, 4, 5, 6. Okay. Another possibility could be, what if we went 1, 2, 3, 4, and then go down, 5, 6, 7. Okay, so now the blue is winning. Let's try this hot pink. Let's see. If we start at the top, 1, 2, 3, 4, 5, 6, 7, 8. So notice that the pink is the longest path here. So I'm going to erase all those shorter ones. The brown one, which only went to 6. The purple one, which only went to 5. The blue one, which only went to 7. And we're left with this pink arrangement, which goes to 8. Okay, so that's our parent chain or our backbone. So I always encourage you to circle that parent chain to help it to stand out from the rest of the molecule. Now we'll learn how to name these branches in a future exercise. For this one, let's just name that parent chain. We have 8 carbons. The prefix for 8 carbons is oct. All single bonds, so the infix is AN. And it's a hydrocarbon, so the suffix is E. Hydrocarbon because we don't see the symbols for any other elements there. We don't see any S's for sulfur, N for nitrogen, O for oxygen, so it's just made of hydrogen and carbon. And the name for that backbone is octane, just the backbone. Okay, let's try F. We've got here, you could go left to right, so it's that 1, 2, 3, 4, 5, 6, 7. That's one possibility. You could go 1, 2, 3, and then go up. That's 4. You could go 1, 2, 3, 4, 5, and 6. So that's not looking too promising. You could go 1, 2, 3, 4, 5, 6, 7. And so it looks like we have a tie. There are even a couple other paths you could do, but the longest paths you can find here would be 7 carbons long. So let me erase these green numbers, which only went to 6, and the purple numbers, which only went to 4. And so we have these 2 paths here. And if you'll notice, these 2 chains give you different branches. If you ever have a tie like this, you want to choose the backbone that gives you the simplest branches. Notice that if you took the blue as the backbone, you would have a branch that had branches on it. Like you get in this branch and here already it's going in different directions. You have forks in the road. So that's complicated. Whereas if you looked at the brown carbon chain, if that were your backbone, notice that the branches are simpler. None of the branches have branches on them. So if the backbones ever tie, choose the backbone that has simpler branches. So that's going to be this brown one here. Now we'll learn how to name those branches in a future video, but for now, let's just name that backbone. We have 7 carbons, so the prefix is hept. All single bonds, so the infix is AN. Oops, should be hept. The infix is AN, and it's a hydrocarbon, so the suffix is E. The name for that parent chain would be heptane. Okay, there's something slightly new in this next exercise, and that is that we have a ring. If you have a ring, especially if the ring has a branch on it, always separate the branch and the ring in your mind. So draw a strict, thick line there. You don't want to cross that line. You're going to think about the two parts in that molecule separately. And you want to ask yourself, okay, how many carbons are in the ring? Well, there's 1, 2, 3, 4, 5. 5 carbons. How many carbons are in the straight chain? There's only 1 carbon there, this one. So we're thinking about them separately. Whenever you have a ring in a straight chain, you think about them separately, you count them up. The one that has more is the parent chain. And so here, the parent chain is the ring. So, because that one has more carbons in it. So I'm going to circle that so it stands apart from any branches on it. Now we'll learn how to name this branch in a future video, but for now let's just name this backbone. We have 5 carbons. The prefix for 5 carbons is pent. We have all single bonds in the ring, so the infix is AN, and it's a hydrocarbon, so the suffix is E. So pentane. But it's not just any pentane. It's going in a ring. If you ever have a chain going in a ring, put the prefix cyclo in front of what would be the name to tell people that those carbons are going in a ring. And so the name for that backbone would be cyclopentane. Okay. So here we are on the last 2 for this type of exercise, and we have a ring again. So anytime you have a ring, separate in your mind the branches and the ring. You want to think about them separately. How many carbons are there in the ring? 1, 2, 3, 4, 5, 6, 7. So 7 carbons. How many carbons are in each of the branches? Well, let's see. This first one has just 1 carbon. And the other one also has just 1 carbon. So which one has more carbons, the ring or the straight chains? You'd think about each straight chain separately. You're not combining those ones. The ring has more carbons, and so the ring is going to be the backbone. So we'll erase those. This is going to be the backbone. I encourage you to circle the backbone so it really stands out from the rest. And so we'll learn how to name those branches in a future video. For now, let's just focus on that backbone. It has 7 carbons. The prefix for 7 carbons is hept. It has all single bonds. The infix for all single bonds is AN. It's a hydrocarbon. You don't see the symbols for any other element there, and so the suffix is E, so that's heptane. Not only that, but it's going in a ring, and so in front of that name, we just have to put cyclo. And so the name for that backbone is cycloheptane. Okay. In the last exercise here, the exercise I, we have another ring, and so a ring with a branch, and whenever you have a ring and a straight chain, separate them in your mind. Think about them separately. How many carbons are in the ring? 1, 2, 3. 3 carbons. How many carbons are in the straight chain? Just 1. So 1 carbon. So which has more carbons, the ring or the straight chain? And it's the ring. So the ring is the backbone. Now the ring it's not always the backbone. It happened to be in each of these last 3 cases, but it's the backbone in these cases because it has more carbons, not because it's the ring. There are other situations. If the straight chain had more carbons, the ring would be the branch. But okay, there are more carbons in this ring, and so that ring is the backbone. Let's name just that backbone. We'll worry about the branch in a future video. Well, we said it has 3 carbons. The prefix for 3 carbons is prop. In between those carbons, you have all single bonds. The infix for all single bonds is AN. It is a hydrocarbon. You don't see the symbols for any elements other than hydrogen and carbon, so the suffix is E. So propane. But it's going in a ring, and so in front of that you put cyclo. So the name for that backbone would be cyclopropane. So hopefully this gives you a sense of how you can use prefixes, infixes, and suffixes to name the backbones or the parent chains of carbon molecules.